Hello. Alright, we're getting started here. Just finalizing a few tweaks and whatnot for OBS. I'll show you my flailing about here as always. Let's see here. Oh yeah. This needs to start. Okay, now it's running. Using a clean, loaded, brand new Ubuntu virtual machine for this. Just so that we ensure that we go through every single step necessary to get started with Go. I don't want to leave any steps out. And this is relatively the same for Ubuntu, sort of for Windows, and definitely very, very similar for Mac. There we go. Let's do this scale mode. Yeah, that's what we want. Alright. So, now I can get you bounced over here. And we have our Ubuntu machine freshly loaded. Make it a little bit bigger. There we go. Now, before diving directly into that, bounce back over here. Things I'm covering today. Basically, if you want to follow along with the book, pick up this book. It's great, by Alan Donovan and Brian Kernighan. It's kind of like the de facto book on Go programming language, and I'm kind of taking cues from it. Everything's not exactly verbosely from it, but a lot of the material will be. So if you're following along, pick up that book and everything will flow seamlessly, and plus you'll have all the code and other little things that we work through in the course there in book format, so you can always take it offline if you want to check it out. And as we dive into this though, I will be adding a bit more to what we're actually doing though. Let's see here. Set scale. Let's do it this way. There we go. One more quick tweak here on machine. Let me get that done. That doesn't quite fit. There really ought to be a snap to functionality or something for these things. There we go. Alright. So now we're ready to get started. First things first, we're going to need tooling to write Go with. For one, we need Go itself. So I'm just going to open up a browser and just type Goland. That's the easiest way to find what you need. And we can go here. You can see some of the other collateral, Twitter, Wikipedia, blah, blah, blah. Go is, of course, like the language itself, is actually out on GitHub, so you can go look at the code that is used for building the tool system around Go itself, which is pretty cool. And they always have cool little Go critters everywhere also, which is kind of neat. So, and it also points you to golang.org to the downloads, which is the quickest way really to get started. This site, which always shows up, I don't want to update Firefox, is one where you can go in and you can actually play around with stuff. Like this first func main example, you can go and actually click execute and it executes the code. I guess it does like a pseudo build and you get the program executed right there. And then you can do like other things too and check it out. Conway's Game of Life, and run that. Boom, there it goes. doing its little asterisks everywhere. So enough of that though. What we need for this machine, we're running it on Linux, so grab the TZ. Now one thing that I did notice, going back over here, if you pull down the Windows or the macOS one, it's an actual installable file. That's pretty cool for a number of reasons. The MSI one will actually put Go in and it put it in your path and stuff like that. The Mac one doesn't put it in your path and other pertinent things that you need to set for your workspace, but it does actually just get it deployed out there in a folder. But with Linux, we're going to actually go through the steps. So these are the same steps that you would need to go through if anything was a little different on your Windows machine or your macOS machine. Same thing here. So let's go check out our download. Where are we at? Oh, for some reason my connection is really slow today. So give that just a minute. And right now, if you just joined, we are currently waiting for this download to finish because my internet connection has gone super fast. Not really. It's ironic that this happens every once in a while, even though I have a gigabit internet connection. It's like, how does that work out? I don't know. So, poke, poke, poke. Oh, it's stuck on 666. There it goes. Come on. Just a minute left. What's the saying about a kettle? Won't boil if you sit and watch it. I feel like the same thing with a download. So what we'll do, once it gets downloaded, is we'll untar it, and then we'll add an export to our bashrc file, which I guess we can go ahead and pull that up. Let's put that over here, and let's use gedit. I believe bashrc. There we go. The existing Linux file always has a bunch of stuff. On Windows, this would be bash profile. I mean, on macOS, it would be bash profile. I don't remember the exact specifics on getting it into Windows, but you go into some user interface and then set the property. And it's the same thing, though. You just see a path, and it says path equals da-da-da, and then you can add extra paths to that path. Are we complete? Woohoo! Finally complete. Okay. So that's in my downloads. I'm going to actually navigate over. Oops, I'm going to have to close this because I opened it in that user interface thread. Let's go to downloads. There we go. And now we can just take this command and it'll untar it into the user local directory, which is where you want Go to be. The installers for Windows and macOS actually put it there. Uh-oh. Cannot open. Let's verify we have local, right? Yeah, that exists. So, oh, of course, I didn't fix this. So I need to change this to the specific OS version. So what we downloaded was 1.114. So go 1.114. Then we need to put in the Linux, and D. There we go. Another thing you'll likely need to do is add sudo. There we go. So now, if we go into user local, there it is. There's the Go directory. Oops, cd go. And in it is various executables, executables and tooling that we need to write Go programs. Now let's go back to our path, and we'll open the bashrc back up. Now if I throw in an ampersand at the end, that'll load it and I'll be able to do other things over here, unlike how I was stuck a minute ago. So I'm going to go down to the bottom and actually add the export path to this path. That's where we installed it to. So that should be all fine and dandy. And it also, the instructions for Mac and Windows are here too, that break down the specific things that you'll need to do for each of those installations. Pretty much you end up with all the same things. You need it in a path, you need it in your, you need to install it to a Go path, and then you need to set the path to that executable, or make sure there is a path set to it. Let's do the test for the installation. Type just Go too. So of course I need a source bashrc. There. Okay, so Go is there. So now let's make a directory for Go. And now follow this context, this convention, because the context is important for Go. There's new features that we might talk about at some point, but right now, a lot of Go development, probably most of Go development, is still done in this exact way. Yeah, Greendorf says his experience setting up Go on Windows has been miserable. I use a Docker container now and skip all these steps. That is definitely a much easier way to go. Much easier. But I wanted to make sure that I've covered these steps, just to kind of cover all the bases. But yeah, the easier way than doing all this is to go get a Go container from the Go hub, the Docker hub, and then just use that. But this is basically what they've gone through for it. Maybe a few tweaks here and there to run the service, if you're going to run a service in it. So let's here Go. I got that now. And then inside of Go, we need to set up our workspace. Again, follow this convention. If you break from this convention, things get pretty weird and will cause problems. Like the Go dependency checkers and stuff like that won't know where to look for things. So we need to make a directory for packages, a bin directory, and a source directory. Source being where we will put all of our code. I'm going to make that, and then all this code will, generally speaking, end up on GitHub usually, and then in GitHub I put most of my code in my Adrian account. So take a look at that. That's basically what your path will look like whenever we set dependencies and things like that, which we'll talk about a lot more in a minute. So that's set up, and then okay, actually I can open that back up, and let's just do a sample file execution, make sure our pieces are all set up in the right place. So I'm going to open up the terminal again and just do all this from the terminal, and then we're going to talk about IDEs, which gets into some fun stuff. So here we go, source, GitHub, Adrian. There we go. Now we're going to do make dir and call this hello world. Let's not do this. Let's do hello world. Snake case. Boom. All right. So in here, I'm going to make a file just called main.go. That's always kind of a good file to start with because you're going to need a main function. And then in that, I'm just going to use just whatever junk editor. You could use VI or something like that. I'm going to use Gedit for right now. There we go. And then I'm going to set a terminal over here as we go through this process. Oops. So the little example they have is package main, which kind of self-references what we're using to start the program with, and dependencies. Then we're going to import one library, and it's part of core, called format. Format basically gives us access to a lot of functions and capabilities around printing output, parsing output, manipulating strings, and things like that. So we need our main function, which is always the kind of inroad for the compiler to build the binary to execute. It always starts at main. As we build more elaborate applications, we will create things far outside of the function main, but you will find that there's always a func main. This kind of has its roots in C, C++, languages like that, where there's always a main function that gets the overall application started, kind of like the boot up function of the application. So then we're just going to do a simple printf, which stands for like print format. So then I can throw a string at it, and then a new line. So that'll say hello world, right? Let's save it, and then let's go build. There we go. So now if we try to run the executable, which we've called, already spaced out and forgot, hello world, right? Yeah. There we go. We've executed a Go program. So we know the Go stack is basically installed and can now do a build and execute a binary of the build. So binary executable being the hello world file. On Windows it would be hello world.exe. On Mac and Linux, same thing. It's just going to be a file and it will be a binary executable. Now you can also do another thing. You can type go run and then the file you want to run. So since we just have one file, I can just run it just like that. Go run main.go, and we get the hello world. Now if I did another file, say touch something.go, and then I built it specifically, I could again say go run something.go, something like that, instead of always typing go run main.go. i.e., what I'm saying is that the go run is whatever you pass it. So the build is going to wrap everything in that package directory. Again, something that we'll talk a lot more about as we move forward with all this. Okay, not going to cover uninstalling Go because as soon as you install it, you'll love it and never want to get rid of it. Ha ha ha. Okay, so next steps. What do we want to do next? First, I want to get some IDEs. Integrated Development Environments. First one I'm going to get is Visual Studio Code. Love Visual Studio Code. It's got lots of plugin, lots of capability for programming in Go, but also a billion other platforms. And the other reason that I use it is because since I'm such a cross-platform, I am kind of a crass cross-platform developer, I like to make sure that my editors will run on basically everything. So right now I'm going to install this here using the .deb, which is for Debian. And since I'm using Ubuntu Debian package installer, go ahead and get that downloading. I like to make sure that my IDEs run on all the platforms that I'm going to want to use them on. That's one reason I love VI, I love Visual Studio Code, I love JetBrains tooling. All that stuff will run on whatever OS I put it on. So the OS doesn't stop me by having some weird proprietary mess for my tooling. So the other thing that I'm going to want to get is the JetBrains tooling. And the way that I do this, since I have a full subscription, and I do highly suggest if you're going to be doing development on a day-to-day basis with Java, or let's say C# on Linux, or Go on a daily basis, I would highly refer their tooling for doing day-to-day development in any of these platforms, because it's really awesome, very, very helpful, very, very powerful. All right, go ahead and get that one going. I need to save that file. So that should go pretty quick. This one is going to take a little bit longer. And note, I just noticed this. So I pulled the Debian package down, and it's saying it's proprietary, but it's an open source solution. It's just that the source Debian package thing, I guess, is proprietary or marked as proprietary. But this is Visual Studio Code is open source. The JetBrains tooling is not open source, but I'm just using it to build stuff. I don't really need to look at the editor, but Visual Studio Code is open source. Just an important thing to note. Oh, it's going pretty quick. I guess my download speed's picked up. Cool. So now we have Visual Studio Code, and we will take a tour of that in just a minute. Let's close goofy old Get It. Yeah, okay, exit. Whoops. There we go. So where did they put it? Oh, there it is. Visual Studio Code. Let's open up the file too. Download. Here's our Go, here's our JetBrains. Let's extract that. And then in the JetBrains toolbox, there is an executable. In pretty much every platform, you can like right-click on it and just say run, but it's basically a script file. On Windows, there's a script file or an executable too, something like that. So pretty straightforward to install. And then that will kick off and actually load the toolbox up here, give you the agreement to sign. And then the reason I installed toolbox first, so I can then go in here and basically sign in and then install any of the packages and have it manage the package for me, which is just that makes life dramatically easier. Since we're doing Go, I'm going to go ahead and get Goland installing here. And eventually I'll go through, and as I use other languages, I'll use like IntelliJ for Java. They got the PyCharm Professional, which is for Python, Writer for C#, RubyMine for Ruby, WebStorm is for web development. Great bunch of tooling. I promise, if you get a license for any of that stuff, it is more than worth it if you're doing code slinging on a daily basis. Alright, so we got Visual Studio Code installed. Alright, looks good. Bogging myself down a little bit. Click, 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 and no response. There we go. Alright, so one thing I want to check is I'm going to actually look in the terminal and see if I can, let's go to my project first. Source, GitHub, hello Adrian, and then hello world. Right? Yeah. And let's see if we can execute code. If you do that from the terminal, as you saw me do just now, you type code space dot, dot stands for this directory that you're on, and it'll open it to that directory. So as you can see, the program we just wrote, here's the main.go file, and as I click on these things, there's the executable, but as I click on these things, Visual Studio Code, just like JetBrains Goland, will determine that a plugin is needed for the particular code and ask you to install it. In this case, there's a Go extension, so I'll go ahead and say install, and it'll go out, grab that plugin, and install it. So that adds rich language support, so the color coding isn't just superficial. It'll actually give us autocomplete and other things. For example, let's see here, it says reload. Let's reload it just to make sure everything's there. Alright, so if I go out here and type format again, and then dot, I'll actually, well, it's asking for even more stuff. So your Go code, Go packages, yes, let's get all of this. Install all, install all. I'm going to look at that package stuff later. So let's see what we get. Print. There we go. So it starts to autocomplete various things. So I'll say this is the second line of hello. Now while we're in here, let's talk about one other thing that we'll see a lot. Let's add a variable. So a variable is basically a thing that you're going to have that's a particular type, particular data type, that you'll assign a value to when you create it or when you're working with it further into the program. So like right now if I say var the thing and say string, I'm going to declare a string variable. Then later on down in the program, like I'll have some things happen. That's just a comment. Okay, that's not executable code. But then let's say after some stuff happens, like I write, let's say there's some other code in the program where some things happen, and then the string needs to be assigned to something. So I'll say the string equals the new value is the world. There we go. So now it's that. More stuff it determines. All right, just install that too. Install all the things for Go, Visual Studio Code. So let it do its thing. And then I want to also say format.print f. And we'll actually just print out the variable. Okay, that's a way you can kind of work with strings and print out things and whatnot. So I feel like I'm going to have to fight with that at some point. Dependencies of dependencies of dependencies. Let's go back over here and get our regular view also. Okay, so we have 3 print things, and we're going to pass this a variable so it prints it out. Then we have the hello world with a new line at the end, and then finally it says this is the second line of the hello world. So Visual Studio Code has another cool feature. If we type or press Control and then tilde, we will get a terminal. So you can also go, there's a command here, it says various things about the terminal, but also if you click View, and let's see, where is it? There it is. Terminal with the shortcut key. Most of the shortcut keys, you can see the shortcut key designator with the command in the menus if you go clicking around up in here. So a lot of useful things there. Alright, so at the command line though, we're going to go build, and then execute hello world again, and look at there. We have the new value is the world, which is that variable. Now I didn't put a new line at the end of that, so it didn't skip anything. It just prints out the next printf statement, which is this one, and that has a new line on it. So then it bounces down after hello world to this is the second line of hello. So let's make that a little neater. So let's actually make this say world, right, like that. And we'll put a new line there. We're going to get rid of this print f. I'm going to use a special character here, set of characters actually. Percent sign, and then I believe S. Bear with me, gonna sneeze. No, okay. life resumes. So and then I'm going to knock this one out. And I don't need this comment, that's kind of peripheral. And let's actually, okay, yep, this is good. This shows the various points. We have the variable, string, declared. Then we have the thing assigned this string value. And then, oh yeah, I'm going to take out this new line and there. So what this is going to do is, since we're using printf, which stands for print format, it'll take, and you can put in these things like %s, which will allow you to take the variable and have it effectively interpolated into the overall string. So this variable here will be put into this value. And we'll talk about what these things are called a little later. I don't want to get into a bunch of verbiage right now. I just want to show you how it works. So now we can clear our terminal and then go run the file, go, boom. And it printed out hello world. So you can see that it took this variable and it's double space here because there's a space here and a space there. I'm going to actually remove that. And it interpolated it into here, put it into the string, and printed it out just like we wanted it to. Now another thing in Go is there's a shorter way to declare variables, which I'm going to go ahead and show you right now. And we could just put the thing :equals the value. And I'm going to completely remove that variable declaration. So this is a short declaration basically. So because I already know the value that I want the variable to be assigned, I can use this shortened variable declaration and assignment in this way. So it's the :equal thing. And what it's basically doing, since I already have that value over there, it infers what type the variable will actually be. And that's very easy for the compiler to do since it already has the variable's value that it needs to have. So in this case, the thing is going to equal a string of world ! New line. So and then when I run that, it's the exact same, but our code is cleaned up a good bit. Alright, so that's a quick little tour of Visual Studio Code and our Hello World program. Let's actually get out of that and go see how our Goland is going. Because this will definitely, this is a good way to see what else we need to do to set up our environment. Visual Studio Code is kind of more extraneous and separated from the environment, whereas Goland definitely looks for and will use a number of the Go tools in the IDE. Don't get me wrong, Visual Studio Code can do a lot of these things, but some of the stuff it simply can't do. Sure, I'll send usage statistics. I like you guys. It's a good crew over there at Goland. So if there's any questions that pop up, definitely let me know. I will be looking at chat every few minutes, even though I unfortunately don't have it on my main screen. I'll show you how this works. So here's OBS, and then here's the actual OS that I'm using to show this all on. Okay, and then back here you can see I'm transitioning between things like this. So then I have to go all the way back to Chrome to see the chat. Kind of a complicated endeavor, but you know, it's worth it. Alright, we're going to open an existing project. I'm going to go back to our little fancy, oh look at that, see, Go, it already knew the path of the assumed conventional place to have Go source code. So I can just navigate further into that. And we're going to open up. So you can see where it's pulled down other dependencies actually. So this is ours though, our hello world. So I'm going to open that. And you just open the directory. You can see the path you're at, and then I'm going to open up the tree. There's our files, our hello world executable that we made a minute ago, and our main.go file. Alright, here you will start to see things pop up as it completes the indexing down here that it needs to set up certain things. Like the GOROOT needs to be selected. Currently it doesn't know where the Go SDK is, so let's move out here and go help it find it. As you remember, during installing, it puts it in user, then local, and there is Go. So I believe, yep, there, it detected it now. So now that it's pointed at the actual toolchain there, it's going to start to know a number of other things that's going to be pertinent to the actual version of Go that we're writing to, which is 1.11.4. So in Goland, we have our code already. We know that executes. There is also a terminal here also, just like in Visual Studio Code, works the same way. I can go type go build or go run and then main.go and boom, magic, right? Great stuff. And its shortcut key, however, is different. So if you go into view though, you can go and say tool windows and then terminal, and you'll see the shortcut key, which is Alt F12. In my opinion, a kind of weird and frustrating shortcut key. However, you can go into file and then settings, and there's a keyboard option in there, key map, and you can change the settings for things like that. So it's broken out by, if you see up here, you can go in and figure out where that is. I'm not going to change it though, because it's not that important to me really. But there are a few other things I like to change. So I'm going to go in and set up more of the Go features. Now we just set the Go root, which is where the executable is. There also often needs to be a GOPATH, which currently is set globally at home/adrian/go, and that's where our three pertinent convention-based directories are. Package, PKG, bin, which is where the binaries go, and then source, SRC, where all our source code goes from our GitHub repositories and things like that. I'm just going to stick with the global path right now, but if you needed to use specific versioning or other little proprietary things, you can actually set up a specific GOPATH directory for just the project, which is kind of cool. But yep, not doing that. This just has various build tags, which are based on the system. I am using Linux. It's on this architecture, so that's all great and groovy. Dep. We don't have Dep installed yet, but Dep is super important. Dep stands for dependency, so for Go dependencies. There's going to be a new way with Go modules to do dependencies, but I'm not going to dive into that right now. We'll talk about that much, much later. Right now we're just going to continue onward with what we have here. Alright, so one thing I'm going to do too, everybody can scream at me if you don't like it, but I like to go in and look at a screen that's not horrifying to my eyeballs. Excuse my sensitivity. I'm going to make this darker. Boom. Okay. Now the other thing, just like Visual Studio Code, but slightly more elaborate on capabilities, is the plugins for Goland. Now, a lot of these things I'm just going to get. I do a lot of bash, so good thing to pick up. I also want the material theme UI. You'll see why in a minute as soon as I restart this. I'm going to go ahead and get protobuf support. I'm going to go ahead and get toml support. So these things are basically plugins that the IDE manufacturer and thus the IDE suggest you need because they're most commonly used, right? Like these are featured, but then there's even more commonly used stuff down here for like Kubernetes, makefile support. Let's see here, Rust. If you're going to write some Rust, I guess, in this thing. Vue.js, Node.js. That's one of the cool things too about JetBrains editors. You can write a bunch of other languages in a language-specific editor, but you don't really have to. I'm going to actually do live edit, get the git ignore one. I want the markdown navigator. A Nyan progress bar. Oh, that looks super exciting. I'm going to get that. Oh, and I want this one to change the string manipulation. Grep console key. That looks good. So I'm going to need to restart the IDE, which is common for plugins. They aren't exactly written in Erlang. And we'll hit OK. It'll say restart, and yes, please go ahead and restart. Hello, Z Shane. That is indeed Ubuntu. I usually use Ubuntu for most of my development. In Go, and all sorts of other stuff like C#, JavaScript, you name it. I'm usually doing it in Ubuntu. Or some Debian variant every once in a while. Oh, it's going through multi-stages of restart here. Yeah, I just set up Goland 2, the JetBrains editor, and it's doing some restarts based on all the plugins I just installed for it. Which partially through the process here it decides, I guess, not to restart. Oh, software, always doing funny stuff. Keeping us on our toes. Ah, there we go. Okay, on this restart, it did everything I think it needed to do. And this is the material theme for JetBrains IDEs. It's super slick. It's a thing that Visual Studio Code has too. But it lets you pick things. It gives icons specific to files. Like right here you can see the JS config, the Kubernetes, or the whatever that square thingy is. Node app.js thing here for the Express.js. And the different skins, of course. You got purple, super bright light, deep ocean, Monokai. Oh, speaking of, which one do y'all think I should use here? Some of these look pretty good. Like I like Solarized Dark. That's kind of neat. Any thoughts on that? Let's hear. There was one dark, Arc Dark, and Dracula. I think maybe I'll go with, I don't know, this deep ocean is pretty wicked. Oh, themes, I always get stuck on themes. I usually use this darker, but I think I'm going to skip that one this time. One light. Which one's one light? Where did that go? Oh, you want me to use the bright one? How about solarized light? Okay. I'll go with one light, what the heck. Then we're going to pick our contrast level. Let's say high contrast. I like it to snap out at me. And then use accent color for themes. That sounds good. Thickness 2. Arrow style. Yep. All good. Now we can get back into Goland. Oh, look at that Nyan Cat action. Hell yeah. That cracks me up. Material thing. Oh, look, it's on down on the little bar too. Oh my god, I got Nyan Cat everywhere. Oh, this is too cracking me up. Love it. Oh my god, this is super bright. Like, if y'all can't tell what up, it's gonna blind me. But I'm just gonna go with the punishment level for myself for now. So, all for solidarity. Okay, so with the bright glow of the one light. A few more things about Goland before we start digging back into Go itself. We talked about the terminal down here. Nyan Cat is busy indexing with his toast, or her toast, whatever. Let's see, can I click add configuration? Oh, I think it has to finish. I think I can pause. Yeah, I want to open the debug. Yeah, I think I need to finish indexing before I'm able to open the debug. So we're going to talk about some stuff while it's running then. So we're going to add, let's see, actually, let's do something useful here. So it's all nice that we're printing that stuff out, but let's cover a few more of the formats for printing. So there's format.printf, which will allow this is the string and a value. And we can put in a value like that. There we go. And then I'm going to do another variable again, the value of things. Now that's a standard printf. Okay. Now we also have format.print ln, which simply means this will print one single line and a new character. But you don't have to put the new character. It's just going to print that line and go to the next thing. And then there is format.print. It's pretty nuts that it's taken this long to index everything. It shouldn't take that long in the future. I'm going to let it finish because I want the autocomplete to come up so I can show you all the autocomplete. We've detected some libraries from 3 minutes ago. So that should pop up in a second. finish. Oh, there it went. Okay. Oh, you can see the red. And Goland will say unresolved reference. I know, because it's not even the thing. So we're going to say print. There we go. So you can see the different print options, right? So there's just print. So if we do that, say, oops, this is printing out. And then let's do a format.print. And then there's F, which we've used, which is format string, and then the various things to pass into it. Then there is the print line. And then there's fprint, sprint, fprint, blah, blah, blah. Basically, we have our three main ones, which are print, printf, and print ln, print line. The other ones for other things, which we'll discuss at a future time. But right now, I just wanted y'all to know that these exist and what they actually mean. So now, there we go. Now we got our configurations. In Goland, instead of going to the terminal every time and typing go run, I can come in and add one of these configurations. And I'm going to set up a go build, specifically so we can just click a button and have it run. So in here you can select a particular file, which would be similar to typing go run that file, like go run main.go or go run some other file.go. But I'm going to do it so that any other files that I add to this project later will build into a singular binary. So I'm going to say package, and it's going to say package path, and it defaults out to github.com/adrian/hello world, because that's the path convention that I gave it in the GOPATH directory, which it also assumes is where dependencies will be set up out on the web. Go is a very web-oriented language in that context. So right now, though, I just want it to run hello world. There's no environment variables, no program arguments. Pretty much just this is enough to get us going. So package, and it'll set up the path. And then I'm going to say OK, and then there it is. So I didn't actually give it a good name. Let me give it a good name, because it says go build this whole slew of stuff. I'm going to just say build hello world. There, it's set up now. And now there's two key buttons you need to know about. There's debug, and then there's run. Okay. So if I wanted to execute to this point and have it stop, I could add what is called a breakpoint, like this. You just click out here in the side of the editor, and then I click on debug. It'll now do a build. As you can see, compiling. Nyan Cat goes running down the rainbow. And when it's done compiling, which it should have been done already, but anyway, let it compile for a second. It's done. It'll execute and run through the program until it gets to the point where the breakpoint is, which looks like it has just done. When it stops, it will pull up the debugger. And in the debugger, you will see all the active variables and what their values are that are assigned to those variables. In this case, all we have is the value of things, which is assigned this value here. This is the active value of the variable right here, and the type. It shows the type too. In Goland, it also shows out here, when you stop in the debug, it'll show in the window all of the active values and variables over here to their right in this little grayed out text. So Goland provides a really powerful way to debug through code in Go. Super, super helpful. From this point, I can continue executing by pressing the play button, or I can just stop it altogether, like if we're in the middle of a big program and we just don't want it to execute through the rest of the stuff. Or I can step to the next line of code by itself, I think, yeah, which is this, or step over. So like if I click this, it should, boom, yep, it just goes to the next line. Okay, almost like I had a breakpoint here, but it's just stepping to the next one. So then if there's this line and then other lines of code, I could just step through each one at a time and look at the values and look at what's happening. It's a great way, like if you're having an error at some point, to step to a point where you know it's executing effectively to without causing an error up to that point, and then you can see all the values before an error is actually being thrown in case things are a little weird. So very powerful feature, and a thing that we don't need to use too much right now, but it's good to know that it is there, and we will use it some at some point. Alright, so let's look at another library and nuke a bunch of these values. Trying to think of something that would be good to do next. I think what we're going to do is we're going to parse some parameters from the command line or something. So basically write a little super simple command line application. So let's do that. We're going to use in the import, actually I won't add the imports just yet. I'll show you a Goland feature which is really rad. We're going to just start writing code in func main. First, let's set up a variable. We'll do var s, and then we'll have a separator, and those will be strings. So again, there's something new. We have s and sep, two strings declared in line. So that's one way to do it. You could also say like var this num and that num and this other num and t4 and call them ints, right? So then you have 4 int values, and you'll notice in the autocomplete there's a lot more types that you can use: int, int8, int16, 32, and 64. That's the bit value and gives you the ability to make really, really big values. Like if I do int64, it's just massive. But we're just going to stick to int for now. We'll get into some of the other specific sizes and everything as we work through parsing really big numbers and things like that. So then we're going to use a Go control structure next. We'll go with for loop, and what this is going to do is it's going to step through a set of values, and we're going to take an action on those set of values. So first we want to start this for loop at 1. So that's what that does. You'll notice the variable assignment operator there too that automatically gives I the value of 1 as a starting point, right? And keep in mind, if you get any questions as I'm babbling through all this, just ask them and we'll get anything answered before we go diving too deep into everything. Alright, and then the next thing is we're going to tell it how to iterate, or what range it's going to iterate over. So in this case, I is going to be incremented, and when it is smaller than or less than the length of the arguments that we're going to pass in, just go with me on os.args for a second. We then want it to stop once it gets bigger than the amount that we have, and then we just do the incrementer I++, and then the body is in braces. That's the curly thing. Brackets are the straight thing. I only learned that after 20 years of programming, just like a year or two ago. I always just called it curly braces and curly brackets, and then found out that braces are always curvy and the brackets are the square things. I didn't need to say that they're the curvy things or whatever. So throw in the braces, and then let's put together basically what our arguments are. Now I'll elaborate on that for a second. So os.args, when we have a command line thing, we execute this at the command line via the terminal. We can pass values to the executable by typing in the executable. Like let's say hello world is our executable, and then we can say the first parameter, which would be the param or whatever, and we can pass in any number of them, etc., etc., etc. You can do a whole bunch of stuff that way. So what we're doing here is basically taking whatever is passed in and we're parsing through it. Okay. So we'll need the separator, os.args, and then I. Now, this is another key point here where we've gotten. So os.args is an array of things. Okay, it's an array of strings, effectively. So when it's passed in, we need to step through each of those items in that array, and when we do that here, so we take the length of it, so let's say there's 10 items in the array, I will continue to be incremented and will step through in this for control structure until we get past that 10. Once it gets to 11, it'll break out of that, and we'll have acted on each of the values. And the way we're acting on the values is we're designating the specific point in the array to get a value and then assign it to S so that we can then later print it out. All right, and then we're just going to do our standard format, print line, and then S to print it out. And then also, I'm going to go ahead and delete these ints. And there we go. That is our program. Now, I could run it from here, but it will basically print out nothing, right? Because the build is just building it, executing, and then nothing, right? But what I could do, if I want to build it and pass something in every single time, I can go in here and add a program argument. And I'll say this is a set of values. It's a sentence, but it's space separated. So let's see what that gives us. It'll show us what our program actually looks at as what type of data type and things. So we're going to run that with that parameter being passed in. And there it is. This is a set of values. So it printed out S. Now the funny thing is, this actually doesn't tell us that much yet. Let's put in a separator so we'll see what the deal is there. So if I run it again, we will actually get to see something interesting. See, this is a set of values. Each of those was passed in as a parameter. That whole thing wasn't a parameter. Each of the words was. So each space kind of delimited or separated a new parameter. If I go back in and change this and put quotes, that is going to give us something different. Now it sees the entire string as one parameter. So note, the strings that are passed in via the command line are parsed accordingly to the way they are in programming. So now let's go out to the terminal and actually look at what's happening, just to make sure we got the base covered here. So effectively what's going on is the build is occurring. So the button does a build and then actually executes the command. But let's just execute the command. So we'll say this, we run it, and oh yeah, we didn't actually, we need to build it once. And then we'll do this, and say this, and you'll see this. And then we'll do hello world and that. Same thing, right? So then hello world, this and that. If we pass it with quotes, it'll take it as one parameter. And again, just to look at it at the terminal, that's 3 parameters. So there we go. That's how you can parse parameters in Go. And again, just to go back and reference, I am going through material primarily from this book. It's a great book, probably one of the best ones to get started with Go programming, by Alan Donovan and Brian Kernighan. And of course, I'm adding a bunch of my own content, because a book is not always perfect, and we can add so many more elements to learning the language here in the Twitch stream. So covering all the material in the book, in case you want to pick it up. It's great reference material, etc., etc. and I'm adding all types of extra bits about Elixir. Yeah, you would definitely learn that by building Elixir. What is it? Olaf B Twitch. That's a good one. Olaf B Twitch. All right. What is one of the next things we want to take a look at? Let's look a little bit more at, I think what we need to look at is some variables. We haven't talked too much about those. All right, so variables. Oh, shoot. Just forgot to mention, very important. Notice I didn't type these imports at all. All I did was type the program. So Goland, the editor, will take this content as we go through it and then decide, oh, okay, like s, sep, os.args, etc. All these things have various dependencies. And if it is a system dependency or something that it is aware of, it adds the dependency automatically. If it can't figure it out, eventually you'll get a little red squiggly line and it'll say can't determine dependency, and you'll have to get that figured out. But otherwise, if you're doing things that it has a library of that installed in the core lib or something like that, then it'll add those dependencies in the import section for you, and you don't have to do it. Really nice little feature. I love not having to think about that up front and just type in code and then boom, they just automatically get populated as I save the file. Let's see here. Let's talk the pedantic details of some moderately, well, okay, I find it moderately boring to get into some of the details here, but let's talk about some constants or other variable details, okay? So when we're declaring things, one of the things we can say constant, let's say boiling. That's a good one. We'll do Fahrenheit equals 212.0. Now emphasis, I put 212.0 because, well, it needs to be .0 because it's actually float, not an int. Okay. And then, oops, I can declare that outside of func main. So now anywhere in the program, I can use boiling Fahrenheit and it'll be assigned 212. That's something that won't change. Okay, so that's what a constant is for, a constant value. I've always kind of chuckled. You'll hear them called constant variables, but it's not variable. It's a constant value that is assigned to a variable element, in this case boiling Fahrenheit. But there's nothing variable about it. It's set to that value, that's what it's going to stay. And even in the real world, boiling is always 212. I guess at sea level. Okay, so that might be variable. Life is complicated. Alright, so we're going to say, we're going to work through this example here. This is actually on page 29 if you have the book. So var f equals the boiling Fahrenheit. So there's autocomplete doing its magical thing. And then var c, we're going to go with f minus 32 times 5 divided by 9. So I'm going to sarcastically say at this point, this is how easy it is to translate between Fahrenheit and Celsius. Why don't we use metric? I don't know. So there we go. F minus, did something here. It's fussing about something. Let's hover over and see. Redundant parentheses. Oh, is it redundant? It doesn't look very redundant to me. Mathematically speaking, you want f minus 32 done first. Yeah, I'm not going to believe the compiler at this point. Yeah. So then, let's print that out. Print f. And here we're going to get into some new things about parsing. Let's say boiling point equals %G, and then F. I don't know how to make the, yeah, that'll work for now. Let's see, Fahrenheit, and say or %G Celsius, and we'll do a new line, and then say F and C. Okay, now this is basically going to process and do the math, the function here, to determine what Celsius is. Okay, and boiling, we start out at 212 period. It's going to take those two, and then it's going to print them out in this string here. So let's run that and see what we get. Oh, let's take out our extra crazy params first. We don't really need those. And we're going to run it from the IDE. Syntax error expected. Unexpected underscore at end of statement. I have an underscore somewhere? Oh, is that? I didn't even see that I had done that. That right there, you have just experienced one of the most difficult things in programming. When you miss one single character and you completely space on calculating it. There we go, boiling point, 212 degrees Fahrenheit or 100 degrees Celsius. So a simple little program shows something about these percent brackets. Let's actually take a look at that though. I'm going to go out to the docs to show you, because there's a whole slew of them. Parsing, Goland. Oh, that's not the file line string. Ah! Oh, I closed the whole editor. Is it string formatting? I always forget exactly what I'm... There we go. So, string formatting. This shows you all of the percent values that you can put into a string and talks about what they are. Okay, so we used %s, which is set up for print format and string, and then you can put in place a string value or whatever. Then there is what we used just now, which is %g. Let's see, where does it list that one out? It's got to have it in here somewhere. I'll just do %g. Oh, it doesn't even show it. So %g is likely some float formatting, I believe, or something like that. But as you can see, there is a lot of them. There's the string one. There's ways to left justify stuff. All types of string formatting for doing it in printf. .x is a hex code. %f, decimal formatting. Float is %e, uppercase E for scientific notation, and under smaller e for regular. We got here's all sorts of stuff, but this is a good doc page to kind of bookmark if you're doing a lot of string parsing, because it can get confusing trying to remember all of those things. Alright, let's see here. Next steps. Alright, let's get into some of the next things here. So we've been working with the main function. That's all fine and dandy, but eventually you're going to need to break code out of that and add additional functions. And the easiest way to do that is to use the function structure in the code. So we just create another func. We can give it a name. Let's call it Fahrenheit to Celsius. We'll write a function for that capability, right? So we'll pass in a value or variable parameter, and we need to give it the type that will be accepted. It'll be a float, and let's go with float 64, and then we'll return a float 64, and then we'll have the body of the function itself. And in that, we'll process this thing, basically doing this action right here on that function. And we'll just go ahead and, since it's just one line, we'll go ahead and do a return the value of f minus 32, and then go 5 divided by 9. There we go. So then we can get rid of this, and we can just pass in, or not pass in, we'll execute the function and pass in the Fahrenheit value. Okay? So there we go. We have now extracted the function here and put it in an actual function that we can call, and call repeatedly. So we wouldn't have to repeat that bit of code over and over and over if we wanted to figure out the Celsius for whatever Fahrenheit value we have. So now if I execute that, of course, we just get the same results. And now you see how you can create a function. And just to elaborate on that a little bit, you could have a function, let's say the name, and you can pass in a whole bunch of parameters, right? You can say, I want this, string, and then you could say another, and it'll be int, and bigger will be an int 64, and so on. Whoops, I do not need to do. There I go, trying to interpolate other languages to this one. Oh, you do need them. Okay. Well, I must have just missed the comma there. Right, and then you can actually return multiples too. You can say, I'm going to return a string, an int, and a Boolean value, let's say. Right. Another common thing that you'll see is one of the values that's very, very commonly returned is you'll see an error. Missing function body. Oh, the body's over here. Oh, I'll probably need to do this. Huh. Is it separator? Yeah, we'll just go with one for a minute. Yeah, I think we don't do it with a comma separator. But and then you say return error, whatever, there'd be function values and parameters and whatever worked on in that function. Okay, that's your next key topic. We talked about declarations a bit. We talked about variables a bit. There's a bunch of different types of variables: bools, floats, strings, ints. I have a post. See if I can actually find it for you real quick. That when I write the blog entry for this particular lesson, I'll reference back to this. But I basically covered a bunch of detail and links to where there's more information about all the variable types and how to really get into the nitty-gritty with those. Okay, short variable, we need to cover that. Go types. That's what I did. Well, as you can see, I've done a bunch of other Go stuff, and I continue to add to the library of things. Data generation timings, Go program structure. Where is the stupid thing? Anyway, there was a post. I'll find it. I'll put it in the blog entry write-up I do of this stream, and it'll make it easier to go dig into all that good stuff. Oh yeah, that's all the data generation library, and yeah, whatever. Also, thanks to Ashley McMara for this badass heavy metal Go critter. My hero. Too awesome. Oh yeah, this is it. So this is the page where I go into details about the, well, first I break out all the reserved words, which is important to know. So you don't try to assign those as variables or something like that. That's going to cause you some pain. Some of the system constants, true, false, iota, nil, and then the types, what I've been talking about here, like int32, 64, uint stands for unsigned int, unsigned int pointer, unsigned int 64, blah blah blah. An error is actually a value type 2, which is kind of a little weird, but that's how it works in Go. So, and then functions, append, make, real, close, length. You saw us use length a little earlier when I got the size of a particular array, specifically from os.args. And we'll definitely be getting into all of those a lot more as they get used in a number of things. And I also talk about the specifics of camel casing and how things like that are expected in Go, and the declaration types. So let's look at some of the nitty-gritty there. I was actually using the Fahrenheit example too. And then even got into pointers. So great link to have. Oh, and I should have kept that up. It's another link I'm going to get you in the blog entry for reference material. Alright, so let's look at short declarations. Or do we want to skip to? Short declarations or skip to pointers? What say you? We're going to do short declarations because we need to do that. Alright, so let's get rid of my function. Oops. Go away function. Alright. Then we're going to go here, get rid of the constant. Don't really need that either. Notice it also takes away imports. Go is strongly typed. And by association, if there's a reference to something that isn't actually used in your code body, it'll take that out. Keeps code clean, keeps the compiler from trying to compile in a bunch of dependencies that it doesn't need, and just, hanging non-functional functionality. Alright, some of this stuff that's pretty nuts, and I'll try to go through in detail so we know this. Let's say you have an animator or whatever, and we're using the GIF lib, and then we have GIF, and we need to pass in various stuff like loop, count, and then in frames. Okay, in frames will be something. What's your in frames? Let's say 60. I think is the value I can. Oops. I need to do a short assignment again. And there we go. Okay. Now this is basically a parameterized set that's passed into the GIF, so you can make a GIF animation. The colon equals is the short assignment, so in frames is assigned to the variable is assigned to the value 60. Okay, or 60 is assigned to the variable value for in frames. Anim is assigned to the object value of the GIF based on that many in frames passed in. And then, like, let's say you have a function And again, don't worry about the things I'm assigning. I'm just showing you how to assign stuff with the short assignment operator. And like we talked about a little earlier, there's, like, let's say you want to just have a basic integer. There it is, ready to print it out. Pretty straightforward, right? So let's get to some crazier stuff. Oh yeah, we also talked about if I have a var and then I, J, P, these can all be strings, right? You can also do var L, M, O or something and make it all ints, okay? You can also do assignments that way. Let's say I have I, J, P equals, and then I'll say 2, 5, 9. Okay, so they're assigned now. Just saying, typed, untyped int. Cannot use 2 as typed string in assignment. Oh yeah, I just assigned ints to the thing. So what I should have done was assign the L, M, O. There we go. So there we go, we've assigned the ints, and then let's do the strings. I, J, P equals, yep, and then whatevs. Alright, so there, then those values are assigned, right? This is a typo. Oh, it's doing whatever. Let's say yeah, whatever. They're now, yeah, okay. Those are actual words. I didn't know yup was a word in the dictionary. That's fancy. So these are underscored with a red squiggly because they're not actually used. It says unused variable. So if we just do a format dot print, let's do F. We'll say strings. Do .s, %s, I should say it. And then that's I, J, and P, right? And then we got format.print F. And that'll be integers. Let's go back to that docs page. What was it for integers? Integers is %d. So not particularly intuitive, but whatever. We'll do %d, %d, and then so L, M, O. Alright, so now you'll see the squigglies go away because it's used. So when you're troubleshooting things, one of the easiest ways to just assign a variable is just to print it out. And that'll get you moving on to the next step, like as you're trying to change a variable as you work through code. That comes in pretty handy. Alright, so that's all fine. Oops. And then let's go down and look at, very important thing you'll see over and over. Let's say we're going to have a file and then an error. Errors are almost always designated as ERR when they are assigned to variable from a function. Like let's say os.open, we're going to open a file, okay? Let's say name, and name will equal whatever file name dot text or something, right? Okay, so if, and this is standard error handling in Go, if that is not nil, the error that's returned from that function, then return error. Okay, that's kind of goofy, but that's the way you can trap it, right? So if it's not nil, it means you have an error. So in our case, actually, let's do this. Let's not actually return the error. Let's print the error. We'll do print line and then pass it the error. Okay. Otherwise, we're going to do print, and we'll do print just this, and then F. So there, we're not using that. So f would theoretically be the file, right? And then we'll say f dot close. And that's, of course, if it gets to that point. So there's no file for it to open, but let's run and see what happens. We should get an error. There we go. So we have our yup, yeah, whatever, which, oh, what did I do? Oh, I used an uppercase S. That is not the appropriate formatter. And then integers are 259. Let's make that a little cleaner and add a new line character and a new line character here. All right. So then we try to open whatever file name.txt, and we get an error, and it says no such file or directory. That makes sense, right? And then we print out nil, which is the F. That's the file. There is no file, so of course it would print out that. But let's be crazy here, and let's actually do main.go. Now this could be any text file. It's not really going to matter, because remember, when Go builds, it's going to build this thing into an executable. And the executable is what's actually running, okay? Not main.go. There's not going to be some magical lock or some crazy thing on that. So let's do a build and then run through that and see if that gets it. I don't know if it'll get main.go because I don't know if it executes from the exact directory space. Oh, but yes, it does. So here's our crazy file. We didn't get an error because it did have the main.go to open, and it opened it. Of course, it didn't do anything with it, and it tries to print it out. But since it's just a binary string. I mean a byte string, and because it's a byte string, it prints it out in this weird, crazy hex format. But that's how you do error handling. That's how most functions, especially from system libraries, execute and return that particular parameterized set of values back. You always get the value that you're kind of processing, and then there's the error. So it'd be like f/error is equal to the result of the os.open function, which you pass in the file name. And there's a lot of other functions too. If we look at the IntelliSense here, like print line, you'll notice Goland tells us what the return parameters are. Here it's in, int, and okay? So same thing as os.open again. So we could be executing these things like this. Like if we assumed that there was going to be an error in format.print for some reason, we could say, okay, value error is equal like this. And then we could do the error handler. If error is not equal to nil, continue, but otherwise run this stuff in the function. And then we'll just say return error or format print line error. Okay. Now let's see, what would make this thing error out? I don't even know. I can't even think of something right off the top of my head that would do that. But either case, let's do a format print, and then we'll print out v. Okay, so what is v? Is this Goland? Yeah, it is Goland. Yes, I'm on that one. Yes, Goland is rad. There, my vote of the day. Whoops. Always breaking something. Oh, there we go. Yep, whatever. 27. So, error trapping that. I've never actually error trapped a print statement until today. But so that gave us, let's see, we got yup. Oh yeah, yup, whatever. And then v is 27. I don't have any idea. I don't know what print statements would return integer-wise and what sense that makes really. But you get the idea. We're trying to trap for an error in case the print, for some weird reason, gets an error, right? I'm sure some way we could do that, but I don't know of any way to make the print statement crap up right now. Let's see. Next things. Oh joy. Let's talk about pointers a little bit. Go back through all of this jazz. Boom. Nuked it. Again, if you're following along, this is the book to get. A lot of the examples that I use are in this book. I wanted to use something like this. This is by Donovan and Kernighan. Totally kick-ass book. Great book to read to get started in Go. I say get started. I mean, it's not like it's just covering just the beginner stuff. They get into some pretty deep code, some pretty deep concepts around concurrency, Go routines, like threads kind of, things like that. So really, really good book. Pick that up if you want to follow along more with everything that we're doing. Just give me a second here. I'm going to look through a few things. Yeah. All right. I'm going to start tearing through some of this stuff. Next thing I wanted to show you is, let's say you have variable x is equal to 1. And then say you have this thing called pointer. It's just p. And it points to the variable of x. Okay. And then we have format, let's print this out. We'll print the memory point of p. I love pointers because they're kind of hard to explain. They're very powerful to use and important, but they so often cause so much confusion. Format print line. Okay, so that's now reassigning the memory space of, get that interface out of the way. Stop it. There we go. Reassigning it to 2 after I print out the thing. And then I'm going to print out x. Okay. Now, what do we think is what here? What are we going to see when we print this out? That's the question, right? So the first one is going to, there's a variable, it's assigned a value of 1. Then we're pointing of this variable at the memory space of x, and then pointing out, or printing out that pointer, right? And then we take the pointer and assign that memory space to 2, and then we print out x. So what are we going to get? Is x actually reassigned here to 2? Is it still 1? Let's run it and find out. The Nyan Cat has executed. We have 1 here and 2 here. Now, do we know why? Of course we do. It's real simple, right? So x is assigned the value of 1, right? Then p is assigned the memory space of x. So p would be pointed to where 1 is stored and thus be 1. Then this, however, the memory space is now assigned to 2. So if it's just assigned back to the memory space, it's forced x, which is pointed at that value, which is stored in the memory space. It's not been moved, but it has been overwritten by this reference point here. So now it would be 2. So now you might ask, why the hell would you ever do anything like this? This just seems weird. Think of it this way. Think of x as pointing to a 40 petabyte bit of data. Okay. Now you wanted to assign a bunch of things around that petabyte of data and basically collect together some actions or values or things that need to be assigned to it and processed. But every time you wanted to process it, you didn't want it to be moved out of where that petabyte of storage is. Imagine a petabyte of storage actually being moved. That would be relatively insane, right? Dream Zealot. Zealot? Yeah, Dream Zealot. You don't want that petabyte of data to be moved around all the time, so what you do is you assign a pointer to it and then reference it. And then only when things need to be calculated or brought up for print or actually moved is when you reassign or displace where that pointer is referenced. And then that way you are not actually trying to move around a petabyte of data. So that's a great That's one of the things I always think about when I'm thinking of pointers, so that I can keep it straight in my head about what I'm trying to do with these things. But you'll probably find yourself rarely using pointers, only in reference to certain functions and things like that. So let's get back to another example here, though. Let's say you have x, y, int. And we're going to do format, print line. And this, again, is an example in the book. It's a pretty nifty one. And we're going to kind of zord all. Oh, what time is it then? And then ampersand y equals nil. Now, what are these values going to be? That's a question unto itself, right? These things aren't even really assigned. So let's run it. Nyan Cat executes. True, false, and false. So the thing is even though we don't see what we're assigned, being that we're referencing the address space of the variables, they still have some type of byte value, even if it's nothing. So is x is equal to x memory space? True. Okay, so it's basically referencing itself to itself at its memory space. And then is x equal to y memory space? No, it's not. So that's false. And is x nil? That is also false. It's a memory space. It's assigned to something. Okay. Okay, so that's a beginning. That's like putting our toe into the really icy cold lake of pointers. But we're going to move on to another way to declare variables and valuables and things in Go. And this next bit is the new function. This is a way to create a variable and basically set it up as a thing. So let's look at one of the declarations here. P is equal to new int. Okay. Now, of course, as you look at that, it's not assigned to anything, right? So let's print that sucker out. And we'll look at its space. Okay. And then let's look at the space equals 2. Kind of doing the same thing we did a minute ago. Print line. Back at it. So basically what this does is this is going to declare a variable with the new function, and the new function is going to assign it a default value, effectively. So if I run it, we'll find out what that default value is. Boom, it is 0. So it's given the value of 0 when you do a new int. Then, when I assign that memory space that it's assigned to, and try to print that out, it's now valued at 2. So let's look at some of the other things, just to see what this new function does for us. Because it's also important to note that the new function is not like new in C#, and it's not like new in Java and other languages and stuff. It works in a generally different context. Let's say string. Oops. What do we get for a default of string? Nyan Cat executes, and we get nothing, which generally means it's an empty string. Not nil, just an empty string. Okay? Now, let's see here. Important thing to note. If you're using new, of course, yeah, it gave it a default value, right? But that value, and the reason I used a pointer to reference it, to pull out the value, is, here's the situation. Let's say I do the same thing here. Are these the same values? Nope, they're not. So like if I do format print line and say p equals q, I am going to get a no. There we go, false. So the thing is yeah, there's 0, but it's 0 at different memory locations. So it's not really the same 0. Okay, lifetime variables. All right. Love when people run into each other on the internet. It's great. Okay, let's talk a little bit about the lifetime of a variable. Right after, needed a drink. I'm gonna lose my voice there in a minute. Actually, we're gonna skip that. We'll talk about that in a little bit. Lifetime of variables, assignments, yeah. Here's a form of assignment we should talk about. Tuple. So we've already looked at tuple a bit, but let's actually look at what that actually was that we did. So let's say we did this, okay? So I'm going to actually declare a function, and then we can look at this thing. GCD. This is an example from the book again. You'll notice the way I'm declaring this function brings up another new point. X and Y are both ints. I can pass in the parameters as that and just offer one notation as to what type it is, and that's fine. So it takes that and says, okay, everything in my parameter list is an int. Now, of course, if I wanted to do the different types, I would have to say, like, X is a string and Y is an int. But, meh. Let's skip out on that because we just want ints. And we'll say for Y is not equal to 0, do a thing. And in that body, we'll say equals Y and X, Y. There we go. And then return X. So let's mess with this a bit. What is that going to give us? We'll do format.print line. There we go. GCD 10 5. Let's see what happens there. And run it. So GCD, finding the greatest common denominator of two integers. So the greatest common denominator of 10 and 5 is 5. Let's try some crazy number though. Let's do so that's pretty straightforward, right? So we know how to find the greatest common denominator. The greatest common denominator of that is 1. That's kind of hilarious. Let's do an even number here. And that gives us 1 too. There we go, back to 5. So that's a fun little function for greatest common denominator. Let's throw in another one. Let's do the Fibonacci. Fib in int, and the body, x, y. I'm going to assign that like that and make it say 0, 1. So that's those values. And of course those x and y will be ints because with is equal to and it being assigned just straight up int values, it automatically makes those variable types ints. And we got a 0. We're going to loop through starting at 0 to the count of n. So n being how far we want to go into our Fibonacci sequence. And x, y equals y, x plus y. Oops, don't give me that one. I don't want all the maths for it. And then return x. There we go. So now, let's get our Fibonacci sequence on. So print line, fib, let's go 5 levels deep. And we'll say, actually let's be pedantic here. We'll say depth, there we go, is equal to 5. And here we'll say depth. I'll take that and I'm going to do print of it and say Fibonacci depth of equals that. I think that's right. So then we'll run the function. Let's get our formatters again. There's D and S, right? So I'm going to do float F, and then integer was, oops, integers. I think D is right, so we're going to go with that. Oops. Back here, we need to do depth. Damn it, come on. Totally hosing my keyboard up. Okay, obviously I can't type this. So I'll copy paste it. There we go. Okay, and then run that. 5 levels deep should give us Fibonacci depth of 5 and 5. Why did I? Oh, print line does not do formatting. So I need to use a formatter, so I need to use printf. There we go. Run that again. And there we go, 5, and then, oh, I guess S is not correct for that. I need to use D there, right? Or no, F. Nope. So S? No, D. One of these blasted formatters will work. There we go. So Fibonacci depth of 5 equals 5. It's about 20. There we go. So the Fibonacci 20 levels deep, 6,765. So there we go. And you get to see a number of additional assignment styles, looping through with 4 again. So it's good stuff. And tuple assignment, as I was saying, this is basically tuple assignment, right? So you can do something like anything where you're I, J, K, 2, 3, 5. It's a tuple assignment. However, tuple is also a value, which means 2 values in a variable, which can be kind of confusing when looking at tuples in other languages. There's tuple assignment and there's tuple data types. So what's your assignability? I think that primarily covers most of what I wanted to cover around data types. That gives you the basis in which to work with data types in a lot of different ways in Go. So let's take a look at kind of want to get into imports and packages and files and all that kind of jazz. Oh, the 1,000,001 things to cover. Let's hear. So let's actually look at exactly that. So let's say I wanted to now get a library pulled into here. It's out on the internet. Something useful, right? Let's look up Golang random data generator. Easy way to look up for Golang stuff, just type Golang in your search engine because Go is treated special like by Google, and that way you can actually find stuff instead of it being a weird 2-letter word that doesn't mean much of anything. Alright, here's a library, a tiny generator of random data for Golang, also known as a faker. So we're going to generate some fake data. Now, we scroll down here, it talks about some of the fake data it can create, like first names, male and female, last names, country names, blah, blah, blah. And it talks about how to install stuff. And this gets into some of the 101 that we need to cover. So the installation to do that is go get github.com /go-random data. Now you'll notice that this path is similar to my local path of where I have my project. It's github.com/Adrian/hello-world or whatever. So if I want to use this, I'm going to copy this, go over here, go down and get my terminal, and then I'm going to type that in, paste, and then run that. Oh, let's see here. Okay, I'm on a brand new machine, so this is the type of error that you would get if you just dived into Go for the first time. Missing git command. Now, this is, I'm just thinking about how this may look. This doesn't have to do with Go, actually. But Go, by reference to this, I notice, uses git. Git, of course, is the source control version tool that Go Git uses right here based on these instructions, which is not something that if you're just getting into Go you would even know. But we need git, and I'm on Ubuntu, so let's hear apt get git, and we'll install it real quick. It's real easy to install on Linux. I don't remember what you got to do on Windows. You run some executable or something, and then on Mac it's kind of the same thing as Linux. You can use brew or something, whatever. Let's see, we're going to do sudo apt get install. Yeah, we'll do git all. There we go. We want to say yes. Just install all of that stuff. That'll take just a second. It's not huge. Oh, and here we go. See, installing Git on Mac. Oh, look, you get a little installer thing. Same thing on Windows. There's a little installer. But blah blah blah. I don't suggest doing it from source unless you really, really, really want to get into Git. But 99% of everything we will do in me covering this course, but also in just like the day-to-day coding that I do in some of my other Twitch streams, you just need the executable to be able to manage your repository. You don't need to dive into a bunch of complicated back-end code or nothing. Yeah, git k. I'll use that some too. I'll probably dive into a fair bit of Git in this course too. I've always found that Git specifics isn't usually something well known, so I try to cover it whenever I'm doing any type of coursework. And using Go, it's super important to learn Git when using Go. It makes the ecosystem more understandable. So if you are diving into Go and have not learned Git, definitely back up and learn that first. Awesome, Adimitruk. Why do you have your two first letters capitalized. Is there a trick to that, or a reason? Just curious. See? Oh, yeah, duh, that makes sense. Now I feel like an idiot for asking that. But hey, no dumb questions, right? Yeah, I've just never noticed that you capitalize both. But then, of course, I don't know. Half the world lowercases everything, half the world capitalizes everything. Who knows? It's always something different. All right, how's our Git going? Oh, it's still working. Probably because of my damn slow connection today. All right, almost there. ManDB. What is ManDB? Is that the man pages? Database of man pages? Triggers for that? Setting up all this stuff I don't know anything about. Oh, libsub identity Perl. That scares me. Mainly just because I don't know anything about Perl. I know about Perl, but I don't know how to write Perl. Getting there. Any second now. And check. Yep, it's there. Woohoo! Life can continue now. So I'm going to go back to Goland, and we're going to arrow key up to go back to that last command, and boom. Let's see. Hey, oh, that was fast. It was super fast. But then, of course, Git and Go are crazy super fast, so maybe everything worked out. Let's see if we can actually use this library now. So I pulled that in. One of the easiest ways to tell if the library is set up for you is go ahead and put the import in. Now, like I was saying, I like to just let Goland do that for me. And since we are in Goland, why don't we just do that? Let's get a silly name, a male name, female name, random gender, and whatever. We'll just pull this whole example actually. Copy and paste coding. It's one of the best ways to learn. Look, it even generates an IPv4 address. That could be handy. So there we go. Grab the whole thing, copy that, and then we'll go and we'll put it right below the other code that we just wrote. Boom. Okay. Oh, there we go. Red squiggly lines. So maybe it does. Oh, it found it. Let's scroll back up and yep, see, since I did the go get, that goes out and actually grabs the library dependency and says, okay, this is going to be one of our libraries we're going to use. And once it does that, then I can just add stuff kind of arbitrarily like this, and it'll know to put in that path for that dependency. Now I also, by doing so though, appear to have unresolved reference GCD. Did I delete? Oh, I copied in too much of the function. That's the problem. So let's go down and fix that. Yeah, so it didn't have reference to that because the formatting of the function was just broken. So there we go. That should fix that, I think. Okay, we still got some red squigglies though, so, or some red whatever. Is this, what is this thing even? Go login, or profile login? The new profile's username is da-da-da, da-da-da. Profile, no. So that's not a, it's not a system thing. I think that's just some crap they're making up for the example. Random data, random generator. Oh, profile. That should be right there. Yeah, profile. Oh. So it looks like what they've done. Here they assign this thing, generate profile, and generate profile is supposed to have some type of values assigned to that object thing, it looks like. But I don't know, maybe that's not actually incorrect. So let's run it. Let's run it and see. Oh yeah, beautiful. So what that is then, the new profile's username is catatome and password is this. So it generated that. That's pretty slick. Look at that crazy MD5 hash. It's beautiful. And then we got country code, which is GB, Great Britain, US, United States. Month, time. So that's how, one, you can generate random data very easily by using this library. Not specifically that I was trying to show you that, but what I was trying to show you is how to pull in a library. So take note, that import, github.com/pallander/go-random data. That's the format. If something's out on GitHub or it's out on some other repository, it'll look like that when you import it. And then you reference it in such a way like this, randomdata.silliname. Now, as we pull in other dependencies, they'll just get added into there, and we'll use go-get to go get the dependencies. Now, I'll also talk about, right now, because I don't feel like there is too early of a time to start talking about how to manage these dependencies. Let's say I put this code up on GitHub. You went and pulled it. You wouldn't have that dependency because there's no way for the application repository to know that that dependency is relevant to have. So what I'm going to use is Go Dep. Go Dep is a dependency manager for Go. Let's actually pull it up so you can take a look at that. And we'll scroll down and take a gander. Of course, another awesome little Go critter running around taking care of all the boxes of package dependencies. Ha ha ha. Yeah, so anyway, Go Dep. On macOS, you brew install it. You can also just do curl install like that, which will work on Linux. And then, I don't know how you install it on Windows. I guess you would have to use Go Dep and then do a pointer and something else. It gets tricky. The easier ways sometimes to do dep, however, is I know, so you can do apt-get dep, I think is the command. Anyway, we're going to, I believe, watch me do it wrong. If I do it wrong, everybody will get to see me fix it. Oh yeah, here's the page. Pacman, install from source, development, uninstalling. Still didn't have anything about Windows. Maybe I'll do a blog entry about Windows later. I don't know. But right now I'm on Linux, so it doesn't matter. I'm just going to run this script file, which makes it super easy. Now, you shouldn't run script files just off the internet. That's not a good idea, right? So let's take a look at it. HTTPS install.sh. You'll notice that that is a raw file from a repo. Okay, so it's from the dep repo. That looks fairly trustworthy, right? So we got our documentation here, talks about what the script does. Now, I've run this file a million times, so I'm pretty trustworthy of it. But I just want to make a point. Don't run script files from the internet at random. And here you can see, however, it goes through, finds bin directory, finds your OS. If everything is installed in the correct convention-based location for Go, this script works flawlessly. So on that note, pull up a terminal, and we'll install this sucker. Boom. Curl. And then we're just going to pipe it to the shell. So curl is a thing that basically issues commands against HTTP endpoints or HTTPS endpoints. And here I'm piping the script into the shell, so whatever my shell is will then execute the script, which in this case is this box that we have right here in front of us. So I'm running it. Aha! Another thing, on a default Ubuntu box, we don't have curl anymore, but that's also easily fixed with a sudo apt-get install curl. Easy peasy. Whoops, got to type the password right. Go ahead and install that. Alrighty, good stuff. Now we have curl, so up arrow again, and we're going to pipe that into the shell and let it install Go Dep. There we go. So if we hit dep, oh yeah. Oh, and there's the apt-get install for it too. So you can use go-dep. I forgot all about that. If we do that, and then we open a terminal again, we should have dep, right? No? Oh, that's trippy. Let's actually do this then. Let's do the sudo apt-get install go dep. Now you can just type apt, but I always type apt-get just because old school. Even though maybe there's additional reasons too that Adam would definitely know. Oh, he's already left though. Enjoy the exercise time. Oh yeah, 8-letter max. Oh, okay, yeah. Yeah, Go Dep from apt-get will install, and that'll work just fine. So let's... Cool, 5 more minutes? That's about how much longer I think I'm going to be going here. But nah, anyway. Let's do dep. Okay, now it's definitely installed. Always good old trusty apt-get. So we get out of that. We'll close this. Now, once you get that installed, one of the things in Goland that I strongly suggest to do is go and let Goland know that you have it installed. So you can go to Settings, and then up in the Go section, you can go in and find Dep, and say Enable Dep Integration, and in the empty part here, which is all kind of weird the way they have it set up, but you can go in and, oh, I don't remember where it is. So here's a mission critical command that I'll probably type wrong 2 or 3 times while I tell you what it is, but let's hear which dep or where dep. No, that's right. So which will tell you wherever the executable actually is located. So when you need the path, in this case user bin dep, I can now just go in and get around all this cruft, go user bin, and it'll find dep for me. Oh wow, think about that directory more. So I'm just going to type it instead of letting it think. And it should, there we go, go right to it, pick it, and now dep will be integrated into the Goland IDE. So by doing so, I can go in and now say, let's hear clear, how do we say? I'm not saying, I'm typing. Then you type dep init for the project. And what dep init will do is go through and find any dependencies, in this case, go random data, and say, all right, I want to lock in on the current version that's being used in the code, pull that dependency, and set it in a file. And there you go, now you see it. So it creates a lock file. The lock file will give that version of that dependency. So whenever we want it again, like when somebody pulls this out of a repository on GitHub, they'll be able to actually get the same dependencies needed with the correct versions using dep ensure. And in the TOML, the additional version is specified. And then some comments too are always in here. So that designates the dependency, but in the dependency that we need though, the actual code, it's pulled into a directory called vendor. And in vendor you actually see all of the Go code itself for this data generator, like postal codes, blah blah blah, all the good stuff. So what does that give us? That gives us the ability to put this code base into a repository and be able to pull down from that repository onto another machine and then immediately use the command dep ensure to then pull down those dependencies. So let's say I just pulled it down. We most likely would not have the vendor directory, so I'll go ahead and delete this just to show what it looks like and what would happen. Now in Goland, you saw that down there just pop up and say, oh, it disappeared on me. Darn it. Anyway, what it said was, need to run dep ensure again because it doesn't see the dependencies that are specified in the GoLock and the toml file. Okay? So what I'm going to actually do though is type dep ensure. And I am going to make sure that I do spell it correctly. Boom. And there's the vendor directory back. So if you had just pulled it down, that would just pull down the dependency and you'd be able to be up and running in no time. Now I'm going to add one other thing. In Git, there is another file called .gitignore. This is where you ignore things that you don't want to check into your repository. In this particular case, let's say I end up on Mac sometime. There's a dsstore file. I don't want that uploaded. I also don't want my executable actually uploaded because that's just per machine. Like if I build it here, it'll run here, but my executable won't run on somebody's machine if they pull it down on Windows or macOS. So I don't want that uploaded. That's dependent to the machine that I'm running the code base on. And then I also don't want the vendor directory to go, okay? Because I want people to pull down the vendor directory, again, based on the specific system that they're running it on. So if they're running it on something that's not Debian Ubuntu like this, they're going to want to have that vendor directory pulled down and the executables built in it and the dependencies, etc., executed according to the specific machine with the specific versions that they want. So with that added, I'm going to also, so you clear this out, Git, I'm going to initialize this as a Git directory, like that. So now if I do a Git status, boom, it's going to say I have all types of stuff I need to add. So the first thing I'm going to do is add the git ignore. It's always my first step because I want to make sure that none of the other cruft gets installed in there. You'll also notice a .idea directory, idea. Okay, the .idea directory is the directory for Goland, and we don't want it up there because that has the configuration values and things for my specific editor. And you probably don't want my specific settings for the editor. You want to have your settings for your editor. So let's get that one and block it out too. So I haven't quite added this one yet. I need to add .ida. There we go. I don't want to add the inversion files right now. Thank you, helper. Also recall, or if you recall, I should say, the .gitignore file, the Go package file for .lock and .toml, I pulled down plugins for each of those when I installed this and got started. You may recall that. If you do, that's great. If you don't, it's fine if you didn't install this up front, because if I had not done it then, Goland would pop up a pop-up and say, do you want to install the plugin package for this particular file type? Super great, extremely handy. Because a lot of time I don't remember to go through and install those, you know, on a new machine. So it's great to just see them pop up when I need them and go ahead and install it right then and just do a real quick restart. So alright, git add .gitignore. Add that now. Do another quick git status. Alright, so now you see it's knocked out trying to commit the vendor, the vendor directory, the executable hello world file, and it's left out that .ida directory. Okay, so that's great. Git, I'm going to now add, oh actually no, it's still got the stupid hello world. Oh, it's because I put a dot in front of it. Let's try that again. There we go. So now if I do a git status, yeah, there you go. So it's gone now. But I do need to add the gitignore file. So I'm going to add that, then commit it. Say first commit, making sure the ignore file is in place. Okay. Oh, again, new machine. So git config. I need to set my params here for my user. So I'll do global. Yeah, global user.email ethernet thrashingcode.com git config. Oops, go back. Global user.name Adrian Hall. That is me. All right, now we can do git commit, or actually up arrows until I get it. There we go. And now that is committed to my Git repo. But I have some other stuff. So let's look at that again. Now, if I weren't going to do this at the command line, one of the great things about Goland is I can hit Control K. Whoops, don't search right now. I'm trying to do something else. Control K, and I will actually get the commit dialog, which is pretty handy and something that's also very powerful from Goland. I can tell it to reformat the code to make sure that Go format is executed like this. And it also formats other little nuanced things, which you can set more specifics of in the configuration, but I just go with the default, because then it's pretty much standardized across whoever's going to be looking at it. I can also rearrange the code, which means it will put it into a logical ordering of where variables should be defined and things like that. Optimize imports. I want it to clean up, take out any non-executing code that shouldn't be there anyway. And yeah, what the heck, update the copyright. It's not even in there right now, but if I have like an Apache license or whatever, it'll look for dates and update the date if it's wrong. All right, so let's say first code commit. And then I'm going to actually check all three of the unversioned files. And you will see the differences in green. It's all additional stuff. Since they're new files, it'll all be shown in green. And then I don't have a remote repo out on GitHub yet where this is going. So there's no push, there's just a commit. And that's all I'm going to do for right now, is just the commit. There we go. And boop, boop, boop. Nyan Cat. Dun, 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 dun. And there we go. Code is now committed. I now have a version history of it, at least in the local Git repository. Like if I do git status down here, everything's synchronized, so nothing to commit. Tree is clean. I'm going to clear that out. And we are prepared now. I'm also going to delete this, actually. Delete this one. Let's delete it anyway. And then I'm going to delete the vendor directory, because we'll just get started by pulling it clean next time. Oh, and there's the dep ensure command that shows up and then disappears. That's frustrating. I had to figure that out at some point. But we can always just type dep ensure. We don't have to click it from the IDE path. But it'll pop up if we ever, for some reason, missing a dependency, which is great. So that's all in there. This is our like pseudo hello world app. Shows us dependencies. We've talked about variables. We've talked about a whole host of things today. I am going to now wrap up. I'm also going to create a blog entry where I add the details of a lot of this stuff. And in that blog entry, I'll have the details, I'll have the code. I'm also going to go ahead and put this in a code repository up on GitHub so you can reference it. I will also reference the book that we're using, that we're going through in this course, and all types of other little goodies to make this as useful as possible for anybody that's diving into Go for the first time. And with that, any other questions or anything, let me know. I'll be hanging out in chat for another minute or so, and I'm always available on Twitter at Adrian, and I guess I have an email address and other stuff. So however you contact me, if I see it, I will respond with answers. Easiest way though is always ping me on Twitter when I'm not on Twitch, and I'll get you some answers. So thanks for watching. I hope that was insightful and useful, and I look forward to episode 2 of this, which will be next Saturday at 10 a.m. And we're going to do the same thing, except just completely new topics on types, getting into some more control structures, and all that kind of jazz. So again, There's the book reference, The Go Programming Language by Alan Donovan and Brian Kernighan. Definitely go pick it up, and I will see everybody next time. Keep trashing.